the Chem Collective digital workbench to collect data for the Buffer Lab. You will find the link for the Chem Collective website in your lab handout. Clicking this link will open it up for you. And I will note that I'm using Chrome here for my web browser, which is one of the ones they recommend, or Firefox. I have been able to use it on Safari as well without any issues, but it seems pretty clunky on my iPad, so it seems to work better on a laptop or a Chromebook computer. I highly recommend that you watch the demonstration video, which will go over a lot more of the features of this digital workspace than we necessarily need in our particular experiment. So I recommend doing that. I'm going to walk you through some of the features that would be helpful to know about for the Buffer Lab. So we are in the default labs setup. And I'm going to start by creating some extra workbenches. The handout asks you to create a total of 6 workbenches, so that is what I am going to do. And this will just help me keep track of which solution I'm working on in the Buffer Lab. And to help me better do that, I will click on each of these workbenches and rename them to the appropriate solution. I see this like labeling our solutions in lab, so it just helps us keep track of what is going on. I renamed that incorrectly, so that should be D. All right, so we have our 6 workspaces set up here. So I'm going to drop into the water workspace again. And this is going to be collecting pH information on the water solutions as described in the lab handout. So I'm going to the stockroom and I click on the jug of water to bring it over into my workspace. I'm also going to grab a container to hold 30 mils of water. It certainly could be a beaker, but I'm going to choose flasks. You can move things around to make them easier to work with. So you could certainly grab from the stockroom, you can grab things like pipettes or graduated cylinders to help you transfer liquids over. But instead of that, I'm going to take advantage of the precise pour mode. So to transfer a liquid, I just move the liquid I'm transferring over. And in the precise mode, if I type in 30, it will transfer exactly that amount into my flask, which is pretty great. Very high precision transfer here. All right, and the handout tells us that we want 2 of these flasks, so I certainly could grab another flask from the stockroom and do the same steps again, or I could right-click on my flask and duplicate it. So that's just a quick workaround. All right, so I'm going to want to rename my flask so I can keep track of what is going on. So to rename it, I click on a flask and I right-click it again and I hit rename. And this is going to be my flask where I'm going to add acid. And this will be my flask where I add base. All right, so once again, I'm going to just move these slightly out of the way. And I'm ready to grab from the stockroom my solutions of acid and base. So here I'm looking for the strong acid hydrochloric acid, and I'm looking for a 1 molar concentration. You can see that's popped up here. And I'm also going to look for a strong base, sodium hydroxide, 1 molar. All right, so in my notebook, before I get started, I'm going to record the pH of the water before anything got added to it. So if I click on the container of water, you can see that this panel pops up on the left, and I can see that my pH is 7. So I'm going to put that down into my lab notebook, and then I'm going to go ahead and do a precise pour of the 1 molar hydrochloric acid. Move that out of the way. And now I can look at my solution with the acid added to it, and I can see that the pH is different, and I want to record that. I'm going to do the same thing with my water to add the base. So once again, pretty much for this entire exercise, we're just using the precise pour mode, and that lets us get away without using a pipette as an intermediate. All right, so here's your water base, and you can see here's your pH, so you want to record that as well. The other thing I will point out to you is if I wanted to keep adding things to my workbench, eventually it will start to get full. So when you're doing a series of many manipulations, once you are done with a solution, you don't anticipate using it again. For example, in this simulation, I'm done with the 1 molar hydrochloric acid. I can right-click on it, and I can remove it. And now I will be able to, I might want to remove a couple of things, and then I should be able to add. I'm not sure why it is saying that. All right, so now it was just hung up. So now I can go and put in things again that I want. So if you see that workbench is full message pop up, you can definitely remove some of the pieces of glassware or solutions that you're done with in the procedure. And that will be important for some of the buffers where you're making dilutions of the initial stock solutions before you are mixing. So just keep that in mind. All right, so the other thing that I'm going to show you is what is available. That would be helpful to know in the stock room. So if we go back to solutions, we'll be using water. Under the strong acid, we are using 1 molar hydrochloric as well as 0.1 molar. So depending on what the handout tells you, you'll pick the appropriate solution. We are also using a weak acid today. We're using 1 molar acetic acid, but there is no 0.1 molar. So if the procedure asks you to make or use 0.1 molar acetic acid, you have to make that dilution in your workbench. Okay, so strong acid, weak acid, we're also using the strong base, so we'll use 1 molar sodium hydroxide as well as 0.1 molar sodium hydroxide, so those are pre-made and available for you. And under conjugate base, you can look for sodium acetate. Here we go. There's 1 molar sodium acetate. Once again, there's no 0.1 molar sodium acetate, so that is a solution you would have to make. All right, so that gives you a quick overview of how to use this virtual lab setup. When I'm ready to move on to buffer A, I would follow the instructions in the lab handout, grab what I need from the stock room, prepare it, and look for the pH values just as we did with the water.